climate is changing. Greenhouse gases emitted by humans are warming the Earth. This has serious implications. Oceans are acidifying. Sea levels are rising. Deserts are expanding, and extreme weather events may become more common or more severe. We can prevent some of these consequences by reducing the emission of greenhouse gases.
This tackles the problem at its root. It's called mitigation.
However, we also have to anticipate some consequences. Since we've been emitting greenhouse gases for a very long time, some changes cannot be prevented by mitigation.
Therefore, we have to adapt to some changes. This is called adaptation.
Both require a lot of effort. Is there no easier way? If we humans are already changing the climate today, can't we just change it intentionally? Let's take control. Welcome to climate engineering. Let's manage the climate on a large scale and with surgical precision. Two methods can help us with that. Either we extract greenhouse gases from the air to slow down the warming of the atmosphere, or we reflect sunlight from the Earth, then temperatures will drop quickly. How does it work? Here's an example. We can capture greenhouse gases by building artificial trees. They remove CO2 from the air.
In principle, we already have technologies that could do that, although they would require a very large amount of energy.
And where can we put the CO2? It needs to be stored safely and for a very long time. And there will be a lot of it to store.
Or, well, we can also sink the CO2 in the sea by fertilizing the ocean. That makes algae grow, and just like trees, algae bind CO2. When algae die, they sink to the bottom of the ocean and simply take the CO2 with them.
Well, that's the theory. But how much CO2 could actually be taken up by ocean fertilization is really uncertain. What is certain is that there would be risks, especially because algae is a key link in the food chain.
Algae gets eaten by small animals that get eaten by larger animals, and so forth. Messing with the food chain can have fatal consequences.
Furthermore, ocean fertilization can cause the production of laughing gas, an extremely effective greenhouse gas.
Laughing gas? Laughing gas? Don't make me laugh!
We have another trick up our sleeves. It's getting too warm. Then let's dim the sun. Sunglasses for the Earth have an immediate effect. Cool! We can, for example, inject sulfur particles into the upper atmosphere to reflect sunlight.
That sounds simple. Less sunlight would mean less global warming. We know that the rising concentrations of greenhouse gases will have serious consequences. But could we actually balance increased greenhouse gases simply by reflecting sunlight? Well, we might be able to stabilize the global temperature on average. But reflecting sunlight does not have the same effects as reducing greenhouse gases. No one can tell exactly what the consequences would be. In some regions, we might have much less rainfall, or sometimes a lot more.
Well, that's great.
It's not certain that this will have negative consequences. Why shouldn't we just try? And if the experiment has bad consequences, well, then we can just stop it.
But if we have to stop the experiment, the Earth would warm in a very short time. We wouldn't have solved the problem with the greenhouse gases simply by reflecting sunlight.
But who gets to decide whether we reduce our emissions or adapt or manipulate the climate? No one has asked me.
These options are not mutually exclusive. Climate engineering can buy us time and is a last resort in case of an emergency.
Aha! And is it you who decides what an emergency is?
Artificial trees, ocean fertilization, or a sunshade for the Earth. Even if technological interventions might solve some problems, they would also create new ones. And it is unclear who should decide about their use. In short, we should think about climate engineering very, very carefully. In the meantime, let's first focus on mitigation and adaptation to reduce the risks of climate change.